Welcome back. In today's video, I'll be revisiting the data model for our application, partially to add some features that we'll need later on, and also just to give more of an overview of some common Redis design patterns that you might run into in your own applications. Redis has some awesome perks in terms of performance and flexibility, but it does require a good amount of consideration from a programmer's perspective to use effectively. In the previous video, we moved our Redis code out of the main application code and into a managed data model package. And that kind of design decision will definitely pay off in terms of manageability. But now I'll go deeper into actually building some data models to abstract over the details of the Redis backend. So let's get started and jump right into some code. The first thing I want to focus on is the user model. And I'm going to create a struct. Which is going to represent our user. So later in our application, we'll have this user object that we'll be able to attach methods to and kind of organize all of the functions that deal with users into methods attached to this user object. So this object is basically just going to contain a key string for now. And this key is a key into the Redis database. So all of the user attributes like the Bcrypt hash and the user's username, and we're going to create a user ID, which is just going to be an integer key. If you're familiar with SQL databases, this is going to be like our primary key. All of those attributes are going to be in a hash map in Redis, and this key here is what's going to point to that hash map with all the user attributes. So all this struct has to store basically is a way to look up that hash map. And then our methods attached to this struct will do the actual Redis lookup calls. So let's build a constructor now that we have this struct. So we'll say func new user. If you're familiar with Go code, you've definitely seen this pattern. We create this struct and then we add a constructor. It's usually called new. So this is going to take a username, which is a string, and it's going to take a password hash, which in this case is going to be a byte array. And it's going to return a pointer to a user and a potential error. And the first thing I'm going to do is create the ID for this user. So like I said, all users are going to have an integer ID, sort of like a primary key. And to do that, we're going to use the increment function in Redis. So this will take any key that we pass to it. In this case, we're going to make up a key, which is going to be user next ID. And if this key doesn't exist in the database, then it's going to start at 0. It will imply that it's an integer because we're using an increment function. So it starts at 0, and then increment adds 1 to it, and it returns that as our ID here. We have to call the result because all of these Redis commands return a different structure that has methods attached to it. Result is one of the methods we can call to get our ID and to get our error. And then with any error that we return, we'll want to handle it in some way. For now, I'm just going to say if the error does not equal nil, we go ahead and return nil for the user and then the error itself. So this error would be if the Redis server is down or something goes wrong with this increment, which is a pretty simple operation. It's probably just that we're disconnected from Redis. But we still want to know that, and we want to end this function right here before we do anything else. The next thing that we're going to do is create this string key for the user. And we could just use the integer as a key, the ID, But we need to namespace it a bit, because if we have different types of objects, like say we have users, and we have comments, and anything else we add to this application, we can't just use the integer key for any of those. So instead we'll prefix them with a string. I'll use the thumped package for that, and we'll use string print format user and then the ID. So the key is just going to be in the form of user and then the integer ID. And this is the first time we've used thumped in this package, so we also need to import that. So now we've got our key. All the other times that we've used Redis, we've called the client commands directly. So we've been using like client.set, client.get. But this time I'm going to use a pipeline. So we'll go ahead and create a pipeline. And what this does is the commands aren't going to be sent immediately as we're coding this. We're going to use multiple Redis commands in this next few lines to set attributes of the user. And normally a Redis command is going to have a round trip to the Redis server. So the set command, for instance, makes a call to the Redis server and then gets a response back. And we don't want to do that for every single one of these because it's just more communication than we need. So using a pipeline is an optimization almost, because we're able to set a bunch of commands and then send them all to Redis, and then Redis will give us a response back in one round trip. So the first thing we'll do is, and the pipe has pretty much all the same methods that the normal client has. It's like an abstraction over the client that does this pipelining for us. So we'll call a hash set with our key as the base key. And hash objects in Redis are keys that have keys, basically. It's like a tiny version of Redis inside of a key. Obviously it's more limited than the normal Redis keys, but we can use it like a hash map or a dictionary, a hash table, depending on how you want to refer to them. So the first key that we'll set will be the ID key, and that's just going to be the integer ID. The next key we'll set will be the username key, and that's going to be that string username that was passed to this function. And the next one will be the hash, which was also passed to this function. So these are all going to be set on this user ID key. And the next key that I'm going to set will be on a different object. This object will be user by username. And we'll set the username and the ID. So to explain this, there's another key in Redis that it's implied that it's created. It'll be created the first time this command is used, if it doesn't already exist. So this key is going to be user by username. And this is going to contain a lookup that relates username to user IDs. This is going to allow us to look up our user by the username. See, if we just use the user ID, we need to know the ID and able to get any attributes from that user. But using this, we can look up the ID from the username, and then we can get attributes using the username. So now that we've done all these little pipeline commands, we can go ahead and execute the pipeline. And I'm ignoring the first return value because it's actually an array of the command results. And in this case, there are a bunch of set commands. I don't really care. I just want to know if they succeeded or not. So we'll ignore that, only focus on the error. and then call the execute method on the pipe, and do our error handling. Same as up here. If there is an error, we're going to return a nil for the user and the error. And then if they get down here, we'll return a user pointer that contains that key that we've just set all these values on, and then no error. And now we can paint some happy little methods on our user object. We'll go down and say func user. It's a method on the user pointer, and this is going to be to get the username. It's going to return a string and a potential error. Okay, and this will just return client.hashGet user.key username. So what this is doing is where we set this for the user key, the username attribute, we're able to now get it as long as we have the user key, which we do because it's in the user object that we created in the response from new user. Now we can just call the result method, which will return a string for what we just got and a potential error if it failed. So do the same thing basically. I'm going to copy and paste that code for the hash, except this time we're going to return a byte array, and we'll obviously be getting the hash attribute for our object. And we won't want the string result, which is the default, so we'll call bytes. And the Go Redis package has this method which will give us bytes or a potential error. So now we can actually write our authentication method similar to what we have here, but we're going to attach it to the user. So this is just going to be a method on the user object. We'll call it authenticate. It's going to take a password, which is a string, and return a potential error. And so if there is no error, then we'll assume that the password was correct for the user and they authenticated. If there is an error, then something went wrong or they entered the wrong password. It'll have to be handled differently depending, but that's the gist of it. So the first part, it's going to be really similar to this, but we'll get the hash and maybe an error. But now we won't be getting the hash using this, Redis client.get command. We have this method here that's going to get the hash for our user. So that's just a nice little convenience. Go ahead and handle this error, which should only happen if Redis is disconnected, because if this is a valid user, if they made it through this portion of being able to construct a user, then the get hash method shouldn't fail unless Redis is offline, which is possible. But in that case, we'll return this error, whatever it was. Now we need to actually compare the hash. I'm just going to copy this. Yeah, that should work. But instead of just returning invalid login, I realized after I wrote this originally that there is another case that could happen. This function could actually fail for other reasons. I'm not sure what reasons. Maybe data corruption, like if the hash is bad. But regardless, it could fail for reasons other than invalid login, and I'd like to just cover that potential chance that it happens. So we'll make another if error equals, now the Bcrypt package has a special error for when the hash doesn't match, and that special error is error mismatched hash and password. So if that's what the error is from this, then great, we know that it was our error invalid login, and we can return that. Otherwise, I'll just return the error from this. So if it does match and nothing went terribly wrong with Bcrypt, then this error is going to be no. So we'll skip this and just return no, which means that they authenticated. So this does everything exactly the way that we would want it to do. Now I guess I can go ahead and try to clean up this authenticate user function. Oh, but first there's a helper function that I want to write, which will be func get user by username. So now we're going to write a function that takes in a username as a string and returns one of our user pointers and a potential error. So when we call this function, we can pass it a username, and if the user exists, it's going to return a pointer to our user object. That's going to be useful for writing the authenticate method, but also for other situations, any situation really, where we need to grab a user by the username, which I think is a pretty common operation. So the first thing we'll do is get ID and a potential error by calling client.hget, and here's where we get to use that user by username hash. Look up the username, and this time I'm actually going to have it return an int 64 because it's going to be that user ID, which was an integer that we set on this hash. So if this error happens to be redis.nil, which is something we encountered down here, in fact, just go ahead and copy this. I'm going to replace all this code here in a second anyway. So if this returns redis.nil, then we can return our error user not found. But we also have to return nil here for the user object, and we have to do the same here. So if it's not this Redis nil result, then we're just going to return a nil user and a nil error if it's a non-nil error to begin with. Otherwise, the error was nil, none of this happens, and then we go down here where we have the user ID, and we can use funct.sprintf, create this user key with the ID, and then we can just return a new user pointer, pass that key in, and no error. That looks about right. So down here, I can actually take all of this off, because a lot of that was actually implemented right here. The Bcrypt hash comparison, the invalid login check, the user not found check, all of that's been implemented in these methods, and now all we have to do is say user, maybe an error, get user by username. So this method is just going to say, hey, I want to get the user that they're requesting, maybe an error. If the error isn't nil, then we'll go ahead and return that error. And that could be this user not found error. It could be an internal server error, which our application will handle in different ways later on. But otherwise, we actually got a user. Let's call the authenticate method that we wrote and pass in that password. And this method, of course, will return nil error if they authenticated correctly, or some kind of error, maybe an invalid login error, maybe an internal server error, who knows. But that's all handled by this method, and now we've just reduced the complexity of our authenticate user method quite a bit. The next thing I want to do here is change the register user method, because this client.set that we had originally isn't going to work anymore, because, well, that's not how we're getting the hashes for our authentication anymore. So instead, we have this new user function, and that's going to handle the registration. So here is the signature for our new user function, and it returns a user object. We don't need to use it. We don't need to use the user. This is going to be a tongue twister. And it returns an error object, which we're going to need to hang on to, because we want there to be an error if the registration function doesn't go through. So we should just be able to say username hash here, and then return the error there. And at this point, I want to go ahead and give this all a quick run to make sure we didn't break anything. Looks like it's launching. So now we'll go localhost 8080 in the browser. Oops, should probably let you see what I'm doing. Okay, so now we're in the browser. I won't be able to log in actually, because the username hash isn't there anymore. We just changed the data structure, so the user that I created in the past is now inaccessible. It'd probably be a good idea to erase those keys from Redis. So I need to register again. If you had actual users on your site, you'd want to do some kind of migration to move those keys into the new form. But since we're still in this testing and developing stage, we'll just roll with it like this. So now I've registered, and there were no errors. That's a good sign. And there we go. I'm able to log in. The comments are still there because we haven't changed the comment structure at all yet, which brings me to the next point. So in the next video, I'll redo the comment model and start to reshape the comments into being more like a timeline or a social media wall for each user. Bye!